So hello and welcome my dear student in my channel A Journey with Physics where quality matters. So today we will start a new class from SHM chapter or SHM section, that is of simple harmonic motion, from the book of H.C. Verma, that is a famous person. So what we will do is that we will solve objective 1 today. So my request is to you, so we just take your pen and paper and sit in front of the class and now actually focus on my words, what you have learned in the previous SHM chapters. So before actually starting up the class, hi, I am Sujit to take today's session with you, and the question will come in front of your screen and you just need to solve the question. And try to pause this video and just give answering from yourself. After that, see my approach. So for today's first question is on your screen. Is a student says that he had applied a force F equals minus of k root x on a particle and the particle moved in a simple harmonic motion. He refuses to tell whether k is a constant or not. Assume that he has worked only with the positive x and no other force acted on that particle, and there are 4 options are listed below and you have to choose which will be your right answer. So I hope you have understood this problem, and now see my approach how we can solve this problem. So before actually starting, before answering this question, so you just need to know some basics about SHM. What are the basics? The basics are that a particle which is executing an SHM motion undergoes an force, and that force is called the restoring force, and the restoring force is related to its displacement F equals minus kx, where k is the constant, that is a spring constant, where k is a constant and we called this k is the spring constant and this is constant. Again repeat, this is a constant, that is the actual relation is equals to F proportional minus of x, where minus sign indicates that F and x are directionally opposite to each other. Now according to given question, the student applied the force which is related by this expression, and the student forget to mention it that k, whether k is constant or not, whether k is constant or not. That means if k is the constant he mentions, then the motion will no longer be a SHM, will no longer be an SHM motion. But the student refuses to accept that or say that k is a constant or not. That means in the question it is not clear from the question, that is k is a constant or not, and the student mentioned that the particle which is under this kind of force is a simple harmonic motion. So when we called a motion a simple harmonic motion, the motion will be called simple harmonic motion if the particle follows that kind of relation. If the particle follows that kind of relation, that is F equals to minus kx. But here the relation between F and x is not like that the SHM motion. So what we will do to show that this motion obeys an SHM motion, I have to modify this equation. And the modification, what are the modification? You have to replace k root x, you have to replace this constant k as some constant k naught root x and root x. If you put the value k is k naught root x. If you put the value k equals some constant k naught and root x, that means this force then can be written as F equals minus k naught x, F equals to k naught x, which is exactly similar like this equation. So to follow an SHM equation, you have to follow an SHM equation, or for a particle to obey the SHM motion, you need to remember two things: that the force should be proportional to x, that is the power of x should be 1. The power of x should be 1. Here the power of x is half, not exactly 1. So to maintain the power of x is 1, you need to multiply by and root x, and this k, if you put this k as k naught and root x, then the relation F equals to k naught x exactly follows the equation of an SHM. Follows an SHM, because we can put k equals k naught root x, because in this question it is not mentioned whether k is a constant or not, k. So if we put k equals to k naught root x, then the relation exactly matches with the SHM equation. Now see, k equals to k naught root x. If you increase x, then k also increases, because k and root x are the proportional relation. There is a proportional relation. Thick proportional relation. So from the among options, option A will be your correct answer. That is, as x increases, k also increases, because you just can see clearly, if x is increased, then k also increases. Then option A will be your correct answer. I hope it is clear. So moving to the next one, and the next question is question number 2. This is also very and interesting and conceptual, because this question can give you a clear and vivid idea about the topic that you are reading, that is SHM. So you just need to practice the H.C. Verma, because H.C. Verma is the brilliant book for concept growing. Okay, now moving to the next question, that is question number 2. So I just take some pause. Now see the question number 2. The time period of a particle in simple harmonic motion is equal to the time between the consecutive appearances of that particle at a particular point in its motion, and the point is which? Take, it is said in the question that a particle which is executing a simple harmonic motion, and the time period of that particle is said to be that time which it crosses that point. It crosses means the particle crosses a point consecutively. So how we will solve this question? So in this way we can solve the question from just our basics idea. What are the basics idea of us? And that is, the time period is that time to have a complete rotation. The time required by the particle is called the time period. We know that. And we have the 4 options: the mean position and extreme position, between the mean position and the extreme position, between the mean position and the negative extreme position. And you know, if a particle which is executing an SHM motion, the trajectory or the path of the particle will be like this. It is said that it is the point, this point is called the equilibrium position or the mean position, and this point is called the extreme right position, and this point is called the extreme left position. If the distance from the mean point is capital A, and this will be definitely also be capital A, that is the distance between the mean position and extreme right position will be same for this case also. So if it is positive, it is said to be the negative distance. So now according to the given condition, the particle covers consecutively that point between its complete rotation or time period. So now if you follow just options, option A, it is the mean position. Option A, it is according to a given question, that is the option A is the mean position. Now follow, if the particle starts from mean position its journey, then either of the side he goes. ठीक. Now we say that the particle goes first in the extreme right position. Now it also, after that some instant it come back in the mean position. So can I say this is the one complete rotation? No, I can say, but the particle crosses mean position 2 times consecutively, because it starts from a journey from mean position and it reaches extreme right position and come back its mean position. So we cannot say it is a time period, the time taken by the particle from making its journey from here to here and come back from here to here. We cannot say it is the time period, because we know the time period is the time taken by the particle to have one complete rotation. Okay, so now follow the option B, an extreme position. The option is an extreme position. So if you just follow this option, now if you just follow this option consecutively, isn't it? So now the particles starts move from here, the particle reaches here, come back here and goes here and come back here. So it reaches 2 times, that is consecutively end position. So first time it reaches extreme right and the next time it reaches extreme left position. In this way he crosses 2 end position consecutively, that is the time taken by the particle to reach end position in 2 consecutive way is called the time period. So if you follow the option C, between the mean position and the positive extreme, so in the first case we have shown you that if a particle starts from here and reaches extreme right position, that is a extreme you can say positive extreme position, then it come back its normal position. This is not the time period. Time taken by this particle to have this motion is not the time period. So again in this way you can also eliminate, that is option D. So option B will be your correct option. That means it is the total time by which or in which the particle reaches 2 extreme positions. One is extreme right and another is extreme left, and the time taken by the particle to do so, to reach extreme right and another and to reach an extreme left on the opposite side is called a time period. Okay, now moving to the question number 2. Now moving to the question number 2. Sorry. Now moving to the question number 3. What does it say? The question says that the time period of a particle in a simple harmonic motion is equal to the smallest time between the particle acquiring a particular velocity v vector and the value of v is. There are 4 options, that is of v max, 0, between 0 to v max, and between 0 to negative v max. So according to also definition, we know the time period. This is the smallest time taken by the particle to complete one rotation is called time period. We know that definition. We know the definition for the SHM particle. What is the time period actually? So in this case, the particle acquiring a velocity, that is a v vector, and you should know that if a particle starts his journey from the mean position and going either of the end position, in which direction it goes, it has to come back in the same direction that in the first case he was traveling. In that case, it has to come in the same way from the opposite end, that is an extreme end. So that means, more specifically we can say, that is, if a particle starts from its journey from mean position towards east, it has to come the mean position from west, that is extreme left end position, and it has to come in a east direction to reach the mean position. Take another again I am repeating this word, that is, if a particle starts his journey from its mean position, if a particle starts its journey from mean position and going towards east to reach extreme right position, it has to come in mean position at the same time from extreme left in its last journey, and the particle also going towards east direction to reach the mean position from extreme left position. Take, that means its initial movement direction and final movement direction are parallel to each other. In this case, the total time taken by the particle to reach the mean position is called the time period. So your answer will be, that is v max, because when it starts from its journey from mean position and also reaches mean position when it about to complete its one rotation, the particle reach the point, the mean position, at mean position. So, and we know at mean position the velocity of the particle which is executing SHM is a maximum. So the answer will be v max. So the answer will be v max. That is option number A. That is option number A. Now moving to the next question, that is a question number 4. We are moving to the question number 4. Now question number 4 says the displacement of a particle in simple harmonic motion in one time period is. First of all, we need to know that the displacement is a vector quantity. If the initial and final position are the same, then the displacement is 0. And we know for an SHM particle to have its one complete rotation, the time taken by the particle is one time period, and during the one time period the particle reaches that point from where he starts his journey. He starts his journey. So during this one time period, the displacement of the particle should be 0, because it reaches the same point from where he initially started his journey. Okay, so again you can think of it is in this style also. For one time period, the motion of the particle can be depicted as by this figure. If it is positive A, then it is said to be the negative A. This is in the positive, amplitude in positive direction, and it is the amplitude in the negative direction. And you just need to sum this process, or just need to sum this value. To calculate the displacement, you just need to sum this value with positive and negative sign also. So that this total displacement will be positive A and negative A, that is of 0. In this way you can think, or in this way, and the first way is the better way. The first way is the better way than the second one, because during one time period the particle reaches that point from where he had started his journey. So that means its initial position and final position are the same. That means displacement will have to be 0. Displacement will be 0. Okay, I hope clear. Now moving to the question number 5. The question number 5, this is also an interesting question. Question number 5. Look at that question number 5. The distance moved by a particle in simple harmonic motion in one time period is. Now we are required to calculate the total distance covered by the particle during one time period, and the 4 options are given. That is, now we are writing the options. 0, that is capital A, that is 4AH. Option B 2A, and option A is A, capital A, where A is the amplitude. You have to think of this. Now according to question, one time period, the total distance covered by the particle, and we know the total distance is a scalar quantity, it is not a vector quantity. So direction is not gonna be essential in this question. Okay, so what is the actual way to think of one time period? And if you draw a picture, and if you take this point is the extreme right point, and this point is the extreme left point, extreme left and extreme right, and we know the maximum displacement is called an amplitude, either side of the mean position. We know the maximum displacement from mean position is called the amplitude. If a particle starts his journey from that position and reaches at that position in the same direction as the direction was his initial journey. So if a particle starts his journey from this mean position and the particle has to come in that position, then we called the time taken by the particle is called a total time period. Total time taken by the particle is called a time period. So now this is your mean position. If a particle starts his journey from this point, the particle has to come in this point, then the time taken by the particle is called the total time period. And during this one time period, the particle, how much distance covered is your essential question. ठीक, is your essential question. Now look at the first step. If a particle starts its journey from this position and reaches the extreme right position, then the distance covered by the particle is A. Again the particle come back in its mean position, the distance covered by the particle is also A. Now from this mean position the particle reaches the extreme left position, again the total distance covered by the particle is A. Now again the particle reaches the mean position from extreme left position, and also the distance covered by the particle is A, because the distance between the extreme right and mean position and extreme left and mean position is always A, that is the amplitude, that is the maximum displacement. So total distance covered by the particle is the 4A. So here gonna be your option, that is a 4A. So remember, just two questions. If it is asked to you to calculate the total displacement, then the answer will be 0 during the one time period, and if it is asked to you to calculate the total distance during one time period, the answer will be the 4A. Okay, the answer will be 4A. So I hope clear. Now moving to the next question, that is a question number 6. Now this is a very interesting question. So the average acceleration in one time period in a simple harmonic motion is how much? It is the question. You have to answer the actual option. So it is the question you are required to answer. The average acceleration in one time period in a simple harmonic motion is how much? So you know the value, one time period, that is one complete rotation. So if you have, and you should know you should keep, always remember this figure, that is x equals to 0, that is x equals to plus A, and that is x equals to minus A position, that is x equals to minus A position. And in this position the acceleration is the maximum value, and you know the value omega square A, and in this position the acceleration also maximum value, and the value is the omega square A, because it is a vector quantity and the vector as a result of vector, the direction of this acceleration is towards positive x direction. That is why the positive sign has come here, and it is the negative sign has come here to indicate that the direction of the acceleration is towards negative x. Okay, it's towards the negative x, and you know that in the mean position acceleration A is 0. So what will be your average acceleration in one time period in simple harmonic motion? Simple harmonic motion e one time period e তোমার average acceleration কি হবে এটাই তোমার বার করতে বলেছে। Now see, we can solve this problem in two ways. One is calculative, that is in that case we need some mathematics, and the second is the on the basis of the concept. So what does the concept says? The concept says that during half time period, why I am saying half time period? As the particle, if particle starts its journey from here, it reaches the extreme right position and come back its mean position. It is the time taken by the particle to cover this is called a half time period. And during the half time period, the acceleration in the mean position A1 is 0 and A2 in extreme right, that is of omega square of A. During the next half time period, it reaches the extreme left position where the acceleration is plus omega square A, and it comes back its original position, that is the mean position, where the acceleration is 0. So in this way, during one time period, the acceleration is changing in this way. So these two values are the during first half time period, and these two values are the for the next half time period for the extreme left position and mean position, extreme right position and the mean position. So you just need to add all those acceleration and you have to divide by the total time period, that is of t. So A max, that is A total, what will be the result A total? You just need, you can see, that is if you add A1 and A4 is 0, and at the same time A2 and A3 is also 0. So total A, that is sum of all the acceleration, is 0. And if you divide to find average acceleration, you have to calculate A total divided by total time period t, that is 0. So in this way you can show or you can have that the average acceleration over the entire time period, that is full time period, is 0. Average acceleration will be 0. And another way we can show the value. That is, you know the acceleration is like this omega square x, and you also know the displacement at a particular time t is represented by x equals to a sine omega t. That means at a particular instant the acceleration is related as omega square a sine of omega t. Now according to the average acceleration definition, we can write average acceleration definition 0 to t a dt, that is 1 by t integration 0 to t a dt. This is the definition of average acceleration. Average velocity will also follow the same definition. So you know the value and you know how to calculate this, because you have learned this calculation from your SE chapter, okay, from your SE chapters. So you know 1 by t 0 to t. Now put the value of acceleration a, that is of omega square a sine of omega t and dt, sine of omega t dt. Now just bring the constant outside of the integration, that is of minus omega square a 0 to t sine omega t and dt. you have to calculate now integration. You have to solve this integration. You have to solve this integration within the limit of 0 to t. Why we have applied the limit 0 to t? Because it is set in the question, that is, we have to calculate the average acceleration during the one complete time period, and we know complete time period is represented by the symbol capital T. Okay, and the value of capital T we know 2 pi by omega. Okay, and we know the value t equals to 2 pi by omega. Now calculate this integral. 0 to t sin omega t dt. So sin minus cos omega t by omega 0 to t. Now minus 1 by omega cos omega t minus of cos 0. Okay, and if you put the value omega t equals to 2 pi, omega t equals to 2 pi, so you put the value of omega t, that is cos 2 pi minus cos 0. Okay, and you know the value of cos 2 pi, you know the value of cos 2 pi, it is of 1, and cos 0 also 1. So the value of this integral is 0. The value of this integral is 0, and if you put the value of this integral is 0, then this part gets multiplied with the 0, so the total outcome is, so the outcome is 0. So the outcome is 0. In this way we can show mathematically the average acceleration over the entire time period, is 0. And also by conceptually we have shown you that is the average acceleration is 0. So I think it is quite simple. So in this way we can solve the average acceleration is 0. That is, the mathematics is soundful to prove this, but concept is more powerful than the mathematics to have this answer. Okay, let's move to the next. No, the bell has rung, so I have to stop this class here. So tada. So you just keep going your preparation, and more confidentially, with more confidence and with more aggression. So just best of luck to all of you. So tada.